Okay, I'm going to start 7.1 today, exploring characteristics of exponential functions. Okay, so an exponential function is in this form, y equals a bx. So if you want to understand the parts of this, b is what I would call your base, because it is being raised to an exponent, and a would be a coefficient, a number that you multiply in front. So our coefficient has to not be a, because obviously if you're doing 0 times anything, it just is always going to be 0. And we're going to talk about b being greater than 0. So we're not going to do a negative base. And we're not going to have it to 1, because 1 to any exponent is always just going to be 1. So that's not going to be very effective in an exponential form. Okay, so we're going to create a table of values. So first thing I do, y equals 10 to the x. So I'm going to go clear anything in my y equals, and I'm going to go 10. Do you remember where your exponent button is? Right here, to the power of x. Okay, so I'm going to hit second function graph, because it shows me the table of values. Okay, so we're going to go, we start at -3. So in other words, 10 to the -3 is like 1 over 10 cubed. So 0.001. 10 to the -2 is 0.01. Okay, 10 to the 0, anything to the 0 is 1. 10 to the 1 is 10. And then you can see 100 and 1,000. Okay, so what is this going to look like? Well, here are my y values. So let's think about what we want our window to be. So we don't have to go very low, so we could say y to -5. And x, we would go fairly high. So let's go to like 2,000. Okay, so -10 to 10, I just have to reset that. We said y is -5 to 2,000 we're going to go. So I want to probably go on my y-axis up by, I don't know, 100 or 50s. What is this going to look like? So you can see that it shoots up very fast. So that's what an exponential equation does. Maybe I'll do a little less y so you can kind of see -500. Just so you can see this as well, that it's just going to approach 0. It's going to be an asymptote. So 0, 1, and then it just shoots up very fast. And as you can see, looking at these numbers, they're just going to get closer and closer and closer to 0. But you can see that you never cross. So if I trace, looking at my y values, see how my y is just getting closer and closer and closer and closer and closer to 0. It's never going to touch 0 or cross 0. Okay, so x-intercepts, so it's never touching 0, so there are none. Your y-intercept, 1. Okay, obviously remember how to do this. Trace, and if I want to trace an x value of 0, you can see 0, 1. And behavior, it goes from quadrant 2 to quadrant 1, it increases. The domain would go from -infinity to infinity, or x is all real. You can see it goes left and right. And the range goes from approximately 0 to infinity. Okay, next one. So now this time we have a coefficient. So 2 times 5 to the x. Okay, so let's check out our table first. So at -3 we're at 0.016, 0.084, 2, 10, 50, 250. Okay, so that's in my table. So therefore, let's adjust our window. We don't need to go this high. So, I don't know, negative 50 to 300, up by tens. Okay, actually I don't need that many x's, so I'm going to just change my x. Let's go negative 5 to 5. Okay, so again, you can see that we're still going to have that point in the middle to start. Our y-intercept is 2 this time. Why is it 2? Well, when we plug in 0, 5 to the 0 is 1, but then we're going to multiply it by 2. And then we're shooting up, and you can see that we're approaching this asymptote. And I'm actually going to draw an asymptote like so. Okay, x-intercepts, well guess what? There's not going to be any because we don't ever touch that line. We get closer and closer and closer to it. So as you can see, we're just going to get lower and lower. Our y is getting lower and lower and lower and lower, right? It's never going to touch 0. Okay, y-intercept. So the y-intercept is 2, and the end behavior is the same. So from 2 to quadrant 2 to quadrant 1, we're increasing.
Did you perhaps find it or no? No. It's probably gone down forever. Somewhere. I don't know. Maybe we'll see after the weekend, right? I guess. Okay.
Have a good one.
Have a good weekend.
The domain is the same, negative infinity to infinity. And the range goes from approximately 0 and up. Or you could state that as y greater than 0. Right? That's another way to write it. Okay, next function, 1/2 to the x. So this time we have a base that is a fraction. So what is going to happen? Okay, so I'm going to go to my table. Okay, this time we have 8, 4, 2, 1, 0.5, 0.25, 0.125. So that's my table. So I'm going to graph this. I'm going to change my window. I don't need to go very high or low, so negative 5 to 10, up by ones. Graph. So this time, that's what your exponential function looks like. So when before we went skyrocketed up, we're going to do that but going backwards. Okay, and similar characteristics, it's going to not ever cross 0. What do you think that intercept is? So 1/2 to the 0 is going to be 1. So if I trace, push the trace button and then push 0, enter, I get 1. Okay, so x-intercepts, there's none. Your y-intercept is 1. This time, going from quadrant 2 to quadrant 1, we're decreasing. Your domain is going to be the same, and your range is going to be the same. Okay, last one. Okay, we have a fraction base again, so my prediction is it's going to go downward. And we have a coefficient, so that's going to change my y-intercept. That's my predictions. 8 times a quarter to the x. So table 512, 128. 32, 8 to 0.5, 0.125. So we're going to graph this. I'm going to change my y window. I'm going to go a max of 750. I'm going to go up by 20s, something like that. And here you can see our predictions are right, that we're going to be going down. And again, it's going to hit that asymptote, or approach that asymptote. And what was the prediction on the y-intercept? So 0, 8. So y, because this raised to the 0 is 1, and then you're timesing it by 8. Okay, so no x-intercepts. Your y-intercept is 8. The end behavior is going from 2 to 1. You're decreasing. And domain and range are going to be the same.